Hi, Carolina. Hello.
Hey everyone, can you hear me all right?
Yes, we can hear you very well. And can you hear us as well?
Yeah, loud and clear.
Great. So, usually I would say at this point, the stage is yours, but I'm just going to say take it away.
Okay. And first of all, apologies for not being there. I had a change of circumstances, kind of a last minute, and I just couldn't make it to be here. So it is awkward for you and equally awkward for me to be presenting at a distance and actually not seeing anyone because I see the back of the room. So I see the slides from the prior session still on the screen. So if you can put mine, that would be helpful. And then we get started. And what I want to talk about is how we are accelerating R&D at Nestlé with generative AI specifically, and other bits and pieces of AI and data also surrounding that. And I will be focusing on from ideation to impact, so more on the product innovation part of it and renovation. Although I will also give you a feel or some ideas of what we're doing in other areas of R&D, because R&D at Nestlé is about creating products and renovating products, but it's also about everything that's around regulatory and scientific affairs, where the excellence is in R&D, and then the execution and operations. And the same about process and technology design and optimization for operations, where the know-how and the excellence is in R&D, and then the execution is in operations. Okay, so you will see most of the examples around product innovation, but the philosophy that we're following also applies to those areas. So if we can move on to the next slide. Yeah. So I want to start with the scale of the problem and opportunity at the same time, because everything at Nestlé is huge, right? So we sell 1 billion products every day, right? And in almost every possible country on the planet, with thousands of brands. Majority of them exist in certain markets, but we have about 30-something billionaire brands that we sell in many markets. Lots of factories as well. Only R&D has 1.7 billion in investment out of a total of around 92 for group sales last year. So everything is big. So every time that I tell you about product innovation, you think that we're talking about thousands of SKUs in the end. Next slide, please. And like I said, I'm going to be focusing on product innovation. And any company in the consumer packaged goods space, fast-moving consumer goods, needs to provide reliable products and steady innovations at the speed that the consumer market needs. Now, optimizing this product development flow is especially, it has always been challenging, but it's, let's say, even more challenging today due to a number of things. And there's a lot of uncertainty due to geopolitical tensions, regulation, and climate change, right? And so we buy billions in raw ingredients, for example, or where we manufacture certain products, and cross-border sale. I mean, there's a number of things coming up from here. There's also rapidly evolving consumer needs and preferences. What we feel they're faster, and the data says that they're faster than ever. Well, a lot of market fragmentation and a lot of niche player competition, and actually GenAI is creating more AI native companies in the food space as well. And you will see how we are tapping into that trend as well, because you can basically accelerate and amplify any kind of innovation. And then we have a lot of supply chain challenges from the sourcing itself, inflation, regulation, and all the things above in the geopolitical tensions, regulation, and climate change as well, right? So our primary use of data, AI, and GenAI is on two fronts here for product innovation. One, can we predict potential for new product innovations so that we are more targeted, and that will increase sales, so increasing the top line? And then can we increase the performance of the R&D projects? Because that reduces the time to market, but can we also cut the tail for those R&D projects where we foresee that we're not going to get the outcome, and cut that as soon as we can? So that's essentially the framework of and the business problem and opportunity at the same time for Nestlé. Next slide, please. And like I said at the beginning, we feel all these challenges at scale, right? And food systems are under pressure. So it is even more imperative than ever that the R&D organization finds ways to manage all those trade-offs between, obviously, the foods and berries that we sell need to be tasty, need to be nutrition. They need to also be sustainable in all, from all angles that you can look at, and affordable. Remember, we sell in over 185 countries, many of which have food instabilities, right? So it is a goal of this company to provide always affordable food. So that is the statement that we've been making over the years, and the statement that actually drives, from a purpose perspective, everything that we do in AI. Next slide. Okay, so this is a super simplified innovation process. It's actually much longer than this, but it boils down to first identifying insights and trends and opportunities at the end of the day, then imagining what we can do with that. So what are the concepts and the reasons to believe, because if there's no reason to believe, nobody will buy the product, and then developing actually those products. And sometimes also the process, the manufacturing processes that go with them, especially if the product is brand new or we're changing the packaging, that might require changes in the production lines. So on the first part, on identified, that's where we look at consumer behaviors, trends, whether those are social, regulation-driven, and possibilities. We're super strong on looking at this, what science and technology can bring, and also new markets, and eventually new categories inside those markets. On the second part, on the imagine, that's where we go into ideation, ideas become concepts. And then we also do all the feasibility checks. Can we do this? Should we do this? From a science and technology perspective, from a regulatory perspective, from a food safety perspective, and so on. And finally, we go into the development, where we prototype the product, including the packaging, if it's new. We formulate the recipe. We do all the consumer testing. And we do the physical testing to predict to measure the shelf life of a product. And you can imagine that if a product has an 18-month shelf life, then the physical testing lasts 18 months, right? So it is quite a long process in some cases. When we renovate process, we still go through identify, imagine, and develop, but it's mostly develop. The first two phases are smaller. The next one, please. Now, if you plug GenAI into this, it's about two things. It's about volume and speed. I put the main driver. There's volume a bit everywhere and speed a bit everywhere, but I put you the main driver in each of the phases. And the first two is about volume. It's about more insights and trends, more concepts and reasons to believe, because what we have is a funnel of possibilities to then ideas, to then concepts. So that the bigger the number at the top, the higher the odds that something interesting ends up being at the bottom of the funnel, right? So in Identify, we use GenAI to surface behaviors, and we look a lot at social listening, for example, for that. Trend surfacing, where we plug into a lot of trends from science, technology, patents, and other sources of information. And then we cross-reference possibilities. So we can jump into connecting a consumer trend with a scientific possibility for a material, for example, for healthy longevity. So we can do those things. In Imagine, it's again about volume of ideas, volume of concepts, and also accelerated checks. So we can launch campaigns, sort of growth hacking, to test ideas. Would our consumers buy that? And we actually do that in something that we call R&D accelerators, where we can go from a lab to the shop in as short as possible. We do a lot of this validation of ideas. And then for the ones that are more successful with these accelerated checks, then we manufacture them at a small scale in a pilot plant. And finally, develop, it's not so much of a volume, but of a faster. I mentioned before, 18-month shelf life takes 18 months for test because it's a physical test. We can test in silico and predict part of that and accelerate that. For example, we can simulate consumers as well. We can simulate parts of taste. Taste and sensory is a very complicated business, but for some parts, we can also simulate that with what we call electronic tongues. We can prototype a lot of the things in silico. We can predict trials, especially if a product is similar to other products that we've done before, and not do all the trials that we would do, but the ones that we believe will give us the recipe and the product that will be closest to the ideal part. So that is what's the kind of the driving factors that GenAI brings to the identify, imagine, and develop, and the kinds of things we do. And then on the next one, I'm going to show you 5 specific examples, and then I'm going to open up for questions. You can find those that we have published on the press. So in Identify, we are doing a lot of science scouting, and you can think our scientists, and we have about 500 of those, generate a lot of state-of-the-art reports. What's out there? What are the white spaces that are left? Where can we play? Where we should tap into partners? Things like that. So that is usually done days, sometimes weeks, actually, depending on the complexity of the state-of-the-art. It can go down to minutes because the scientists can actually tap into a lot of data sources, things like ResearchGate, Elsevier, patent agencies, and we can look what's other, also internal information that we have from trade secrets, knowledge that we acquired over the years in our innovation renovation projects. So we tap into all that information, which is largely unstructured. And then we can create those state-of-the-art reports. Obviously, we can do other things than state-of-the-art, but that's the main use case. We're also doing something that might seem like very kind of basic, which is equipping everybody in R&D, actually everybody in the company, with tools like, if you're familiar with that, Microsoft 365 Copilot, that embedded in all the Office tools so they can get time and headspace back. So we've been doing this for over a year, largely over a year, and fully rolled out since April this year. We're getting about 10,000 hours per week back. It's about a population of 4,000 people. That's self-reported. Time back, it matters. Headspace in R&D probably matters more than time, because that's where people can focus on identifying and on imagining and on their creativity. So we have high adoption and usage, and we're starting to measure intensity to then relevancy of the use of this kind of tools to empty the agenda of our very highly qualified R&D people. We have 60% plus with PhDs, so that they don't have to do meeting minutes and that they draft documents and so on much more quickly. On Imagine, we're using GenAI for concept generation. We're going between 20 to 50% faster, depending on whether it's a product innovation, renovation, and also depending on the category. We have categories that are more complex than others. But for example, here you have a real example of a seasonal product. We can do a lot of commercial innovations, many more. And we're now also testing, plugging that into our capacity in the factories, like good concepts that we can manufacture, and we increase asset utilization as well. Okay. On this, by the way, unstructured information and making sense of that, we're using that across operations as well for things like risk assessments and assessing all the contaminants not in real time, but in as close to real time as it gets, versus doing that once or twice per year. So you can see that the volume and the speed play in other places as well. And finally, on develop, this one is not so much of a volume, but about speed. So we are discovering new packaging materials and other types of materials. But this is a very nice example we worked on with IBM. It usually takes years because you need to identify the polymers, right? The packaging material. It actually protects the food from air and from moisture. Those are the things that degrade food. So we put polymers and paper for our paperization strategy. So with large language models for chemistry, we can create monomers with GenAI, and then our experts turn those monomers into polymers, and then we synthesize them and so on. And so something that would take years now takes months. Okay, and then that is something that helps us tremendously in our sustainability commitments. And we are doing similar things also for plant breeding and farming for regenerative agriculture. All of this in develop is very, very targeted towards sustainability. For now, we are also optimizing processing operations using this type of approaches. But there's two of the examples that are more mature for us on plant breeding and farming to come up with, in this case, coffee varieties that are higher in yield and they're drought resistant. As well. So you have a feel for what we're doing with GenAI and very concrete examples that you can find out there. If you're interested, I can also send you examples of what we've published and share these examples. And I believe I'm on top of the time and opening up for questions. You can go to the next slide, the final one.
Okay, thank you, Carolina. For the ones that have joined a little bit later, just to know, Carolina joined us online, so that it kind of felt surreal, like there was no speaker on the stage, so that you know that too. We have Carolina here with us virtually. So we still have some space for questions. Does anybody want to ask a question? We have someone there, and you'll get a mic so Carolina can actually hear you.
Hi, Carolina. Thank you. My question is mainly on prototyping. So before your first prototype is built, how do you come, and while you are in the ideation phase and conceptualizing, how do you come together as a team to structure? Because it's often the problems need to be defined well, and you're looking into abyss and it's a clean slate, right? So how do you come together as a team to structure yourself to make that ideation more tangible and just know exactly what to do?
Now, that's a great question. And so we spend, I would say, probably more time on this than actually how to use the tools. Because when we ideate, then we have experts on all the different functions or disciplines that are needed. Like we have nutritionists, we have creative chefs, and especially if it's a category like food, but you need to put the food in a plate, right? It's not snacking, you only eat the snack, but in the category of food, you eat that thing with others on the plate. So you need the chefs. We got people that are specialists in food safety. We got our process experts. So sometimes the teams are like 20-ish people. And so we started testing that in quote unquote our easier category. Easier, why? Because it's only one ingredient and the rest is process, which is coffee. And so they started streamlining the process. How would they do identification and imagining and concept generation if they were all remote and augmented by AI? So they developed a blueprint on how to do this. And when it was more valuable for them to get together and brainstorm like in a whiteboard, and when the technology should come in. And then that blueprint has traveled across the different categories that added their tweaks on the things that were different for those categories. But that is a living blueprint, by the way. And as GenAI can do more things, we keep revisiting that. But that is a number one. In the prior session, we were talking about, how are people upskilled and how do they change, or do we change our ways of working because of this technology? It's a continuum thing. But yeah, you're absolutely right. When we conceptualize and prototype, we do still need all those different areas of knowledge, and still the teams are big.
Great, thank you. Do we still have any other questions? We have here a gentleman in the front. So you'll get a mic so Carolina can hear you. And also, can you introduce yourself?
Thank you. Hi. I guess I have to look that way to see Carolina can see my face. Hi, Carolina. Thanks for these talks. Interesting. I'm representing a company called Avisight. We help companies like yours understanding consumer behaviors in African region, really specifically that region. One of the things we found out during working with a lot of companies like yours is the lack of data consumer behavior in this region. So you just mentioned being able to predict consumer behaviors, maybe also creating some kind of persona, and based on those things being able to predict certain things. I guess you also found out these things the data is lacking in those areas. How are you coping with this kind of challenges?
Yeah, you're absolutely right. So the data that's available is about certain types of consumers in certain parts of the world. Absolutely right. So for example, in China, in Greater China, we have different ways of doing that because the consumer behaviors are very different. The access to data is very different. I think you mentioned Africa. In Africa, there's like big holes in data. What we do is we have a regional center there in Ivory Coast. So we rely a lot in our people in the regional R&D center and the local partners that they have to actually get us that data and to build that data together through the classic things of consumer surveys and consumer groups. We have observation rooms as well. That's for the humans. We also have similar things for pets as well. where we have an ecosystem also with the veterinaries and pet owners to help us get that data, because we have a very big pet care category. But yeah, the access to data on consumers is very uneven, I would say. And so where it doesn't exist, we partner up with our own R&D people on the ground, and with different partners that can help us. And over time, we will get data about everything. But
Thank you so much. Well, can we please give a big round of applause for Carolina also, that she just joined us like that?
such is life. Hopefully next year I'll be in person.